Hi everyone. We ended the last lesson talking about the ionic compounds or how they react with each other. I'd just like to start talking now about the elements within a group and a trend that we see regarding how they react. If we look at group 1, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and even francium at the bottom. In their ionic state, they all have a +1 charge. They all lose one valence electron. However, if you put lithium in water, you see a very small reaction, kind of fizzles in the water and then it disappears. If you put cesium in water, you will not just get a fizzle, you will get a massive explosion. They both lose one electron, but cesium does it much more violently than lithium. And why do you think that is? It has to do with the number of shells each element has. As you go down a group, the number of shells increases. So even though they all have one valence electron, the number of shells it has goes up. Meaning, let me illustrate it. Here's our nucleus. Imagine we had the case such as hydrogen, which has one valence electron. In this case, the electron is much closer to the nucleus, right? It's really, really close to the nucleus, which means the attraction between the electron and the proton is very strong. As we go down the group, I mentioned that the number of valence electrons the number of shells increases. So now, in this case, we have our nucleus, but we have 1, 2, 3, possibly even 4, and our valence electron is all the way out here. What do you think is happening between the attraction? So we have the attraction between the nucleus and the valence electron here, and the attraction between the electron and the nucleus at the top of the group. As we go down the group, the attraction between the valence electron and the nucleus gets weaker and weaker and weaker because it's further and further away. That is why cesium is so reactive. It is because the electron that it loses can be lost so quickly because of how far it is from the nucleus. That is why cesium is very reactive, very dangerous. It is almost giving up its electron so easily. Rubidium, cesium, and francium. Francium is very hard to even find in nature because it is so reactive that when it is exposed to the air, it explodes. Cesium, you can actually get, but it has to be in a very protective container. And even the smallest amount of that element can be explosive and very destructive because it is extremely willing to give up that electron the minute it encounters the opportunity to do so, because it has such a weak attraction to the nucleus. Hydrogen, or lithium, their valence electron is so close to the nucleus that it really needs that push to let it give up its electron. It doesn't react very quickly. Unlike the elements at the bottom of the group, very reactive. So a trend you'll see in the periodic table is as you move down a group, the number of shells increases, and even though they have the same number of valence electrons, because the attraction at the bottom of the group, their electron to the nucleus is so weak, they are highly reactive and extremely dangerous.